this example, we'll look at analysis of a truss using shear force and bending moment expression. So here we have a truss of 12 meters. The whole span here is 12 meters, 6 plus 6. The height is 6 meters. This height should be here. So let's clean up this. Okay, this is what we have. 6 meters loaded with point load, 2 point loads of 10, 20 and 20 kilonewton and 10 kilonewton respectively. So the next thing we need to do here, we find our reaction A. If this is supported here, has a support here and also another support here. So we have to find reaction A and reaction D. So we need to find reaction D and reaction A. So we take moment about D to find reaction A. Reaction A multiplied by 11 arm, which is 6 plus 6, 12, minus, here we have, this will be acting at half of this, which is 3 meters from here. 3 plus 6, which is 9. We have 20 times 9, minus this is 10 kilonewton acting here, and half of this is 3 meters. So it's going to be 10 times 3 is equal to 0. So here we have 12 reaction A minus 20 times 9. We have 180 minus 30 is equal to 0. So here we have our reaction A will be equal to 180. Take this to the other side to change to plus because of this equality sign. So this one also will change to plus, which is 30. Then we divide both sides by, because this is supposed to be 12 A, so divide both sides by 12. So what we'll have here, our reaction A will be equal to, this is 210 over 12. So our reaction A will be 210 divided by 12, which is 17.5. So we have our reaction A as 17.5 kilonewton. Our total load will be equal to 20 plus 10, and this is equal to 30 kilonewton. So our reaction A, the reaction B, or D, the reaction D will be equal to 30 minus 17.5, and this will be equal to 12. We have 12.5 kilonewton. So we have 12.5 kilonewton. So the next thing we need to do here is we will analyze the axial forces on each of these members. Here we consider different joints. We have different joints. We have joint A, we have joint B, joint A, we have B, we have C, we have D, and we have E. So using joint method, we're going to use joint method for the analysis of truss. So analysis of trusses. So here we have consider our joint A. We start with joint A. Joint A. In joint A, we will have our reaction is, and then we'll have this inclined member, which is AB, and we'll have AE. So we'll have here we have AE. This is AE, and this is AE, and this is AB. Call this AB. So this is our reaction A. We already know these as 17.5 kilonewton. So this angle, we need to look at this angle. This angle, let's determine this angle here. Remember that we have from this, we have this angle where the sides have angle of this form, but this is 3 meters, and we have the height here given to us as 6 meters. So this angle is going to be tan 6 over 3, tan theta equal to 6 over 3. So theta will be equal to tan inverse of 6 over 3 is 2. So we look for tan inverse of 2 and see what we'll have. So here we have our angle as, we have this angle, since here we have this, because this is an angle where you have two sides are equal, this side and this side are equal. So we have 63.3. So if we have 63.3 here, the angle, because tan inverse of 2 is equal to 63.4. So all we need to do now is to determine our reaction A, that is the force member, the forcing member A, and member AB and AE, to know if it is in tension or compression. So we need to resolve this force. Let's take this convention. If we take this convention and this convention, let's see what we'll have. So we're going to have, we resolve our forces. We look at, we say sum of vertical forces equal to 0, sum of horizontal forces equal to 0 from equation of statical equilibrium. So here we have, when we resolve this towards this side, what we are going to have, we resolve upward and downward. So if we are resolving downward, it is sine, it is cos. If we resolve upward, it is going to be sine. So we have, for our summation of vertical forces, is the summation sign. So let us wipe this to have enough working space. So what we have here is summation of vertical forces equal to 0. So what are the vertical forces? We have reaction A. Then since if we resolve this, it is pointing upward, which is reaction A is still pointing upward, plus sine 63.3 equal to 0. So it means we are looking for AB sine 63, sorry, this is AB sine 63.3 equal to 0. So our AB sine 63.3 is equal to minus reaction A. So divide both sides by sine 63.3, divide both sides by sine 63.3. So our AB will be equal to, our reaction A is minus 17.5 over our reaction, our sine 63.3, or 63.4, not 3, rather, it's 63.4. 63.4. Change this to 63.4. So what we have here is sine 63.4. What do we have? That's 0.894. So for the horizontal forces, we have two, which is AE. We have AE and we have AB cos 63.4. So what we're going to have here is, for horizontal forces, we have AE plus, because if you resolve this, they're pointing towards the same direction, plus AB cos 63.4. So equal to 0. So AE is equal to AB cos, we already have AB. AB is minus 19.57 cos 63.4, and this will be equal to, so we have minus 19.57 cos 63.4. we'll have minus 8.76 kilonewton. So the next thing we will need to do is to consider the second joint, which is joint B. Because we'll start with the simplest, which is joint A, move to joint B. Once we will get joint B, we will start with joint D again, find this and then find this, then before we finally get joint A. So the next thing we need to consider at joint B, let's clear our space, working space, so that we can, let's clear this. At this point, we need to consider joint B. So we have joint B, joint B. So at joint B, let's draw out the possible forces that we have there. We have the first one, the load acting downward. We have the other one, AB, and we'll have AE, and we'll have BE, and we'll have BC. So this load here, remember that this one is acting downward, and from our calculation, this one was pointing this way, and this one, we don't know where it is going to. We can decide to put it this way also, and put this one this way. So here we have, let's write out the values. These are joint B. Here we have 20 kilonewton. Here we don't know what this one is. This one is BC, member BC. This is member BE, and this very one is member AB. This is AB. So at this point, we already know what AB is. AB is equal to minus 19.57. So what we need to do here at joint B, we consider summation of horizontal vertical forces equal to 0. What are our vertical forces? We have 20 kilonewton. We have 20 is going downward, so it's minus 20 kilonewton. Here we have another one, which is we need to resolve this and this. So remember, at this point, we have to consider our angles. If at this point what we had is 63.4, so the other end will be, here will be 63.4, here is 63.4. Then the balance of what we have here, we're going to share into 2. So at this point, we have 180. We have to say 180 minus 63.4 minus 63.4 divided by 2. That will be the angle we have here, which we need to resolve to. So here we have 180 minus 63.4 minus 63.4. We have 53.2, which we divide by 2. So I have 26.6. So at this point, what we'll have here or here, we'll have 26.6. So here is 26.6. So we try to resolve this. Resolving this, if we are resolving vertically, it is cos, and if we are resolving horizontally, it is sine. So if we have here, it means this angle we are having here, we're going to work with the balance of this angle, because what we have here is 90 minus 26.6, which is 63.4. So here is 63.4. So here, if we resolve this way, we consider this angle, if we're using 26.6. So we have summation of vertical forces. We're talking about this very one acting downwards, then this one is going this way. It's supposed to be plus, it's going upward, but when we resolve it, it's going upward. So but we have minus already, which is AB plus AB sine 63.4. When we resolve this, then we have BE, this BE plus BE. We also have here, we have 26.6. So we have also 63.4 here. So this is going to be plus BE. BE, since we are resolving vertically, is still going to be BE sine 63.4 equal to 0. So here we have, we substitute, we have minus 20. AB is minus 19.57. So we have minus 19.57 times sine 63.4 plus BE sine 63.4 equal to 0. So here we have a value of the sine 63.4. We have, which is 0. We're going to have 19.57 times 0.894 plus 0.894 BE. BE 94 BE is equal to 0. So here what we'll have here is when we multiply 0.894 by 19.57 times have minus 19.57 times, when we multiply by 0.894, so have a value of, what we'll have here is minus 20 minus 17.49 is 49. Then we have plus 0.894 BE equal to 0. We have it equal to 0. So all we need to do is minus 20 minus this is minus 37.49 plus 0.894 BE equal to 0. So our BE will be equal to when we take this to the other side, it will change to plus. So we'll have plus 37.49, which we divided by 0.894. So here BE is equal to 37.49. We divide it by 0.894. This will give us, this is equal to 41.94 kilonewton. That's our value for BE. So we now have BE, and we have AB, and we have AE. So the next thing we do is to go to the right hand side, joint D. So let's wipe the board so that we can go to joint D. So we need to note these values we are getting. So let's note the values down so that we can record them. These values that we have, we need to note them down. We have, from what we've done so far, our AB. We need to have AB. We need to have AE. We need to have BE and also BC. We have CD or DC. We have DE. I'll call this CD or DE, whichever one. So all these, we need to put them in, these are members. All these members, these are members. Then these are their forces. So AB, we have AB. Our AB is minus 19.57. We have AE, which is 8.7 minus 8 point, this is still negative 76. Then we have BE as 41.94. These forces are in kilonewton. Put them in kilonewton. Then we're looking for BC. We are looking for DC or CD, and we're looking for DE. So for us to do that, we move to joint. Let's clean this. We can clean this so that we'll have. So we consider joint D. That's the next. We start from joint D because we've been able to evaluate the forces at joint A and B. So we'll go to D so that after finding D, we get joint C, and then finally we get joint E. So for joint D, what we have here, let's draw out what we have here. We have a force acting here. We have the next one. So the forces. We have the one acting here. So here we have, this is DC. Call this DC. And we'll call this RD, reaction D. We'll call this DE. And this still remain 63.44 degrees. That's what we have here. So what do we do next? Summation of vertical forces is equal to 0. So what are the vertical forces we have here? We have reaction D going upward. This will be reaction D going upward. When we take this one, let's assume this one acting this way and this is acting this way. So we'll resolve this upward. We should have we should have plus DC sine 63.4 degrees equal to 0. Let's split this. So here we have our DC. Remember that RD, we got it initially as 12.5 kilonewton. So here we have DC. When we take this to the other side, it will be equal to minus RD divide by sine 63.4 degrees. So this will be equal to minus 12.5 over sine 63.4. So that is what our DC will be. So what we'll have here is we'll have minus 12.5 divided by sine 63.4. This will give us a value of minus 13.98 kilonewton. So we've been able to get DC. The next thing we need to evaluate is DE. So we say summation of horizontal forces equal to 0. So horizontal forces, we try to resolve this and add it to this. So we have this will be equal to, we have DE. DE is acting towards the left minus DE. Then when we resolve this, it will still be acting minus DC cos, since we are resolving horizontally, cos 63.4 degrees. So here we are looking for DE. Our DE, this is equal to 0. So here we take this to the other side. When we take it to the other side, so that we can find, we're looking for DE. So we take this to the other side. So we have minus DE is equal to DC cos 63.4 degrees. So here we know that when we divide by minus negative, we're going to have DE is equal to negative of what is our DC. Got DC as, with that negative multiply with this negative, we have positive 13.98 cos 63.4 degrees. So here we multiply that, we say 13.98 multiply cos. So what we have will be 6.259, which is 6.26. So we have 6.26 kilonewton. So we have gotten that. So we move to joint C. Our joint C, we draw out the possible forces that we have there. Joint C. If we draw that, we are going to have this. Let's use ruler. Let's use a straight line. So here we have this. We have another force acting this way. We have another one acting this way. Then we have another one acting this way at joint C. So at this joint, we recall that already we have one that is going this way. We said this one is acting this way. And for this one, let's take this one that is acting this way. Then the other one, at that point, we got our BC as, we got our value for BC, we got AE, BE, then BC, we got BC earlier. So here we have our 10 kilonewton. This is 10 kilonewton. We have 10 kilonewton, which is this joint C. We call this joint C. So here is our DC. Is DC. This is CE. Call this joint here CE. Call this very one BC. We could have found BC from joint B, but since we did not do that, let's use this. So here we have summation of vertical forces is equal to 0. We want to find, we already know what DC is. We got DC earlier. So we have here our vertical forces include, we have this one is acting downward. So it's going to be minus 10. So I have minus 10. Then we'll have to resolve this. We'll resolve this and we'll resolve this. So we're going to have DC minus 10 plus, because this one is going upward, DC, we're resolving vertically, it will be sine, DC sine 63.4 degrees. Then this one is also acting plus the acting upward. We'll resolve it this way. It will still give us CE sine 63.4 degrees equal to 0 is equal to 0. So here we already know what DC is, so we're looking for CE. So all we need to do now is to move this and this down there. So we have our CE sine 63.4 degrees is equal to, I'll move this to the other side, changes to 10 plus minus, because we'll take this to this side, the quality side, which is the right hand side, it will change to minus DC sine 63.4 degrees. So we divide both sides by sine 63.4 degrees. Divide both sides by 63.4 degrees, which is sine 63.4 degrees. So this will go with this. Here we have this, we cancel this. So what we'll have here is our CE. Our CE will be equal to 10 minus DC. So what we'll have here is 10 minus 30 minus DC, and our minus DC here is 13.98. So we add it, because it's minus with this minus, it will change to plus. So CE will be equal to 23.98. So we already have our CE. So we resolve horizontally. So here we can also write here, since we already have our DC, we write it here as minus 13.98. Here we have our CE, which we did not include here, CE. We have it as 23.98. So the next thing we need to do is to resolve horizontally. Let's wipe the board so that we can do so. So wipe the board. Go ahead to resolve horizontally. Horizontal forces, a summation of horizontal forces is equal to 0. So our horizontal forces we have here We resolve this horizontally and resolve this horizontally with this. So we have already BC, which is pointing towards the right. So we have BC is going to be positive. Then this very one, when we resolve it, is going to positive plus CE. This is CE cos 63.4 degrees. Then this one will resolve horizontally is going to be minus DC cos 63.4 degrees equal to 0. So what we need to do, we are looking for BC. We already know what DC is, and we already know what CE is. So we'll go ahead. We have BC will be equal to, when we move this to the other side, is going to be minus CE cos 63.4. This moving to that side will be plus degrees. So here we have this. So BC will now be equal to, BC is equal to, here we know that our CE, we are looking for, we know we have CE already, which is this. Our CE is, this is minus 23.98 cos 63.4 degrees. Then DC we have minus 13, so it's going to be minus, instead of plus, minus 13.98 cos 63.4 degrees. So our BC will be equal to, when we multiply 23.98, multiply 23.98 by, we multiply it cos 63.4, we will have minus 10.74. Then here we have minus, we multiply 13.98 cos, we said 13.98 cos 63.4. What we'll have is minus 6.26. So what BC will be equal to minus this, minus 10.4 minus 6.26. So we'll have a total of 16.99. We have 16 minus 16.99.999, which is approximately minus 17 kilonewton. So from here we have our BC as minus 17.0 kilonewton. So here are the forces, the various forces available. We have DE. We have our DE is 6.26. So we put it back 6.26. So you can see from here we have the various members. Among these members, we have a total of 1, 2, 3, 4, 5, 6, 7 members. 1, 2, 3, 4, 5, 6, 7 members. So out of the members, this one, the negative one here is, these ones are compression. These are compression. So here we can say positive equal to tension. Here we say negative equal to compression. So you can see from here we can assign our, with these values we've gotten so far, you can see that the ones that are, because this is tension, while this is compression. So you can see the ones that are like AB is negative compression, so we'll have something of this nature. We have BC negative compression this way. We have CD negative, which is still compression this way. We have ED or DE, which is positive tension, which is this way. Then we have AE is negative, it's still compression this way. Another force we have there is BE. BE is positive, it is tension, we have it this way. Then the next one we have is CE. Our CE is positive, which is tension this way. So with this, we've been able to get all the axial forces that are acting on this truss. So you can see the members AB, then we have AE, we have BE, you can see BE, then here we have BC, and we also have CD or DC, whichever one. They have DE, you can see. So we have CE, so the values are here. So we have 8 members here, and these are the axial forces acting on the members.